I have a challenge for you before we look at the new data, and I need you to trust your gut on this one. I want you to close your eyes for a second and imagine a fire burning in the dark. When the flames die down and the smoke clears, does that mean the fire is out, or does it just mean the fuel has changed? I want you to look at the images I'm about to show you, images that span an entire month of observation from the most powerful telescope we have. Do you see an object that is dying, or do you see an object that is simply going silent? I want you to go to the comments section right now and type FDIMG if you think this is the end of the show, or hey DMG if you think the sudden drop in activity feels suspicious. Because when you compare the optical pictures with the radio signals we just picked up, the story gets complicated. We have received a fresh batch of data from the Hubble Space Telescope. These aren't just the pretty publicity shots NASA usually releases. These are scientific plates processed specifically to bring out the faint structures hidden in the glare. These images tell a story of time. We are looking at a 4-panel comparison spanning from November 30th to December 27th. This is a crucial window. It covers the object's journey as it moves further from the Sun, and it gives us our first real look at how 3I Atlas reacts to the deep freeze of space. Same telescope, same filter, same processing. The only variable changing is the object itself. Let's start with the earliest frame from November 30th. In this image, the activity is undeniable. There is a strong, narrow jet pointing directly toward the Sun. In the world of cometary physics, a sunward jet is a sign of intense, specific activity. It means a vent on the surface is facing the star and blasting material out with enough force to fight against the solar wind. The outflow here is dense, sharp, and defined. At this stage, 3I Atlas is wide awake. It is dumping tons of dust and gas into space. If you were looking at this frame alone, you would say this is a hyperactive object, potentially even a breaking nucleus. It looks like a machine running at full power, but watch what happens as we move forward in time. We jump to the top right panel, December 4th. Only 4 days have passed, but the personality of the object is already shifting. The jet is still there, the geometry hasn't changed, which tells us the rotation axis is stable, but the energy is different. The brightness has dropped. The outflow looks thinner, like a stream running dry. It is the same structure, but with less intensity. It's the first sign that whatever volatile ice was powering that initial burst is starting to run low. Then we fast forward to December 12th. The trend is now undeniable. No new jets have appeared. There is no fragmentation, no explosion, no drama. The plume is getting broader and less concentrated, spreading out like smoke dissipating in a still room. The sharp, defined edges of the November jet are gone, replaced by a soft, fuzzy glow. And by the time we get to the final frame on December 27th, the jet is a shadow of its former self. It is weak, faint, and short. The overall activity level has collapsed compared to where we started in November. When you look at these images in isolation, the conclusion seems obvious. The direction is stable, and the structure is consistent, but the engine is running out of fuel. There are no sudden rotation changes, no new vents switching on to replace the old ones. It looks like a steady, predictable decline. To confirm this, analysts applied an on-sharp mask filter. This is a technique that subtracts the fuzzy background to show the sharpest gradients. Early on, the coma was clearly asymmetric, lopsided, pushed by that active venting. But by the end of the month, the unsharp mask shows a coma that has relaxed into a round, sleepy ball of dust. The violence, it seems, is over. If we only had the Hubble images, we would close the book on 3I Atlas right now. We would say it was a standard comet that had a brief outburst and is now going back to sleep. But that isn't the whole story, because while the visible light is fading, we just got a completely different kind of report from a different part of the spectrum. While Hubble was watching the dust settle, radio astronomers were pointing the upgraded Giant Metrewave Radio Telescope at the same patch of sky. Radio telescopes don't see dust, they see energy. They see ionized gas, magnetic fields, and plasma. And the report they just released shows something the cameras missed. The data comes in the form of a contour map. The colored lines you see represent signal strength. Red and yellow are strong, blue is weak background noise. And right there in the center, sitting in the silence, is a glowing, elongated shape. This is a radio detection of 3i Atlas. Notice the shape, it's smooth, it's continuous. There are no multiple peaks, no jagged edges. This tells us the emission is compact and coherent. It isn't a cloud of random debris, it is a single, unified source. The most shocking part of this report is the signal strength, 10 sigma. In the world of radio astronomy, anything above 3 sigma is considered a detection, 5 sigma is a discovery, 10 sigma is a shout. It is a loud, clear, undeniable signal in a quiet room. So, we have a paradox. Visually, the object is fading away. The dust production has stopped, but in the radio spectrum, it is singing louder than ever. Now, before we jump to conclusions about beacons or transmissions, we have to look at the physics. A radio signal like this fits the profile of plasma interaction. Even if the comet has stopped throwing out dust, the nucleus itself might still be highly charged. As it moves through the solar wind, it creates a bow shock, a ripple in the magnetic environment of the solar system. The radio telescope is seeing that interaction. It is seeing the invisible shield around the object. This changes the narrative. It suggests that while the surface activity, the venting of ice and dust, is dying down, the electrical activity of the object is still very much alive. It is still interacting powerfully with the space around it. Different wavelengths, same object, two completely different stories. So here is where we stand today. Hubble gives us the visual confirmation that the physical outburst is ending. The jet is gone. The coma is round. The dust is settling. But the GMRT radio data warns us not to look away just yet. It tells us that the object is still hot in the electromagnetic sense. The open question now is simple. Are we watching the final, dying breaths of a comet as it freezes over for the long journey home? Or is this radio signal a sign that the object's core is different from what we thought? Could it be a metallic body holding a charge long after the ice has melted away? That's the data. Optical is fading, radio is active. Think about the fire in the dark. Do you stick with your vote? Is it fading or is it hiding? Is the show over or has it just switched to a frequency we can't see with our eyes? Let me know what you think in the comments. We will keep watching every wavelength from light to radio until 3i Atlas is gone for good. Stay curious and stay tuned.